Hello everyone, welcome to mitramath.com. Today we learn the converse of the Pythagorean theorem, which is called Pythagorean Triple. We look at some examples like this, and also we check how it works with geometric shapes and also in word problem. If you need basic review on Pythagorean theorem itself, I recommend watching my previous video for more detail. I have put its link in the description below and also at the end of the video. Okay, without further ado, let's get started. Okay, what is a Pythagorean triple? Pythagorean triple is a set of three whole numbers that satisfy the equation a squared plus b squared equals c squared. Let's practice over an example. Determine whether the given set of measures form a Pythagorean triple or not. Okay, first step, let's substitute those values in our equation. So pay attention that always these three numbers just already ordered based on A, B, and C. So let's plug them in formula. Would be root 3 over 5 squared plus root 6 over 5 squared, which is B, and the last is 3 over 5 squared, which is C. Use calculator or any method, find the values. Root 3 to the 2 would be 3 over 25. Root 6 would be 6 over 25. And 3 over 5 squared would be 9 over 25. Keep this one unchanged and add these two guys. We will end up with 9 over 25. You will see the left side is exactly to right side. So our answer should be yes. But the answer is not yes. The answer is no. Why? Because we had two conditions, satisfy in equation and B whole number. While root 3 over 5, root 6 over 5, they are not whole number. So as a result, they can form a right angle triangle. These three numbers, they can just form a right angle triangle, but they are not Pythagorean triple. So as a result, the answer is no. They are not a Pythagorean triple. Another example. Example says, find the value of k, find k, given that this set is a Pythagorean triple. It means already we know that they are Pythagorean triple. We are going to find what would be the k if they are Pythagorean triple. So let us start to plug them in a formula. It means we are going, this one is A, this is B, and this one is C. We are going to plug them in the Pythagorean formula. So A squared plus B squared equals C squared. A here is 8, would be 8x squared plus B is k. K to the 2 is equal C. C is k plus 2. You need to raise it to the 2. Okay. 8 to the 2 would be 64. K to the 2 is k squared. And k plus 2 to the 2, you need to write them twice somewhere. And then apply FOIL rule. Simplify the terms and just record here the final result. Final result would be k squared plus 4k plus 4. So now we are going to solve this equation. I'm going to send all these three terms left side. So I will get 64 plus k squared. And if I move the terms, I'll get negative k squared minus 4k minus 4 equals 0. Yes? So these two terms cancel out. I'll get just carry down 64. 64 minus 4k minus 4 equals 0. So if I simplify these two constant terms, I'll get 60 minus 4k equals 0. So therefore I have 60 equal 4k, divide both sides by 4, so therefore k is nothing but 50. K or 4 cancel. 60 divided by 4 would be 15. Therefore k should be 15. In this example, we are going to use the Pythagorean theorem on this geometric shape to find the unknown length DC. Question asking you, find the value of DC. It means from D to C, we are looking for this length. To find that, the strategy is that just look at the figure and find a right angle triangle. As you see, there are two right angle triangles. One is this small one, and the other one is the whole shape. There are two. We are going to apply Pythagorean theorem in both of them. So let us start with the first one, the small one, triangle ABC. This one, the blue one. I'm going to apply the Pythagorean theorem here. So if this one, let's say, is A, that one is B, this one would be C, yes? Let's apply the Pythagorean theorem, which is A squared plus B squared equals C squared. Just plug the value in this formula. A, we don't know, but the A is BC, yes? I'm keeping its own name, BC squared. B is 15, 15 squared, and C is 20, 20 squared. Therefore, BC squared, 15 to the 2 is 225. And 20 to the 2 would be 400. Yes? Now I'm going to move this term other side to isolate BC squared. BC squared would be 400 minus 225. Yes? Okay. Then, if I subtract 400, take away that, I would get 175. Now we are going to take a root from both sides, a square root and a square root. So then I'll get BC equal, if you use your calculator, it would be almost 13.25, and the unit is centimeters. Keep this one, we will back to that. Now we are going to work on other right angle triangle, which is the whole shape. And it would be like this, the green one, yeah? So again, I'm going to apply the Pythagorean theorem on this green one. So on the green one, again, we have A squared plus B squared equals C squared. Having that, so from B all the way to D is my A, yes? I'm keeping its own name, which is BD squared. B again is 15, raise it to the 2. C is 25, raise it to 2. So just calculate. BD squared, 15 is 225, equal 25 to the 2 would be 625. Again, moving this term to right side, I'll get BD squared is equal 625 minus 225, yeah? So therefore, BD squared would be, if you subtract them, you will end up with 400. Yeah, would be 400. Now we are going to take a root from both sides. The square root, a square root. We will end up that BD is nothing but 20 centimeters. So, good. Now we know that. We find that the BC, this part, is 13.25 and whole is BD is 20. In other words, from here to here, we find that is 20. And from here to here, we got it 13.25. Yes? To find DC, which is this part, easily we need to subtract. So, therefore, DC is nothing but 20 centimeter, take away 13.25. So, therefore, DC would be almost 6.8 centimeters. It's easy, yes? A word problem. The mast of a sailboat is supported by wires called shrouds, like in this figure. So, therefore, shrouds are this length and this length. Question asking you, what is the total length of wire needed to form these shrouds? So as you see, these shrouds are located in right angle triangle. We have two narrow right angle triangle, one in right and one in left. Yes? And as you see, the mast from top to the bottom is leaning down and intersecting the width of the boat in the middle. So it means if the width is 9, we have 4.5 here and 4.5 here. Yes? So the height of the mast is nothing but adding 12 and 26. It means the total length of mast is 38 feet. Okay, let's just draw a triangle similar to one of them, like this. So now I'm going to transfer information that we got. So we got that the length is 38 feet, length of the mast. And because the width is 9, we got 4.5 here and 4.5 here, yes? So as a result, this length is nothing but 4.5 feet. I'm going to label hypotenuse as y. Okay. Now let's substitute and plug those values in a formula. We have the Pythagorean formula, c squared a squared plus b squared. Just plug the values. So therefore, hypotenuse, the hypotenuse is y. Therefore, y squared is equal 4.5 to the 2 plus this leg, which is 38 raised to the 2. Use your calculator. We end up with those values. Add them up the right side. We get 1464.25. But we are looking for y, not y squared. So as a result, we need to take a root from both sides. A square root from both sides. We end up with y is equal 38.3 feet. It means one of those hypotenuse is 38.3 feet. To find the total wire for shrouds, we need to multiply it by 2. So as a result, the total wire that we need is 76.6 feet. Great. That's all for today, guys. Thank you for watching. I am a mathematics teacher. Love to share my years of experience with the student everywhere. If you find this video helpful, please like and subscribe and leave your comment below for me. And if you need more practices, please visit my website mitramath.com. Under tab free practices, you can find more practice. See you in next video. Till then, take care and goodbye.